Okay, I think so. We're recording there. All right. Yes, we are recording. Yeah, so we'll be lost. We'll lose that recording because of the black holes. We have to just. I'll just quickly go back what we did. So we were talking about a circle, right? Just rehashing what you did for the last course. Circle is basically a locus, or it's a path traced out by points that are equidistant from a certain center, right? And we're going straight to when the center is not at the origin, right? So we pointed out that, let me see if this, yeah, this thing is not going to work here. Yeah. Yeah, we're going straight to when the center is not the origin. And this is one form of the equation. We also have another form, and that's this form here. Um, my tablet is even because I'm now using a laptop. Yeah, this is another form here, right? Uh, yes. And from this form, we can now figure out the center and the radius by just comparing, coefficients and doing some substitution and so on. And then we looked at our first example. We looked at our first example. I switched from my desktop to my laptop. My hands keep going to the mouse ever so often. Yeah, we looked at this example and the two ways that we can go about getting the center as well as the radius, right? By completing the square or by um, by comparing with the general form of the equation, right? Yeah. And then we were discussing, I think we were discussing this equation now, right? That's this equation here. Why it looks a little different. There's a two there, there's a two there, and so, but it can very well be a circle, right? And we talked about the quality of the coefficients of x square and y square. There's a plus between the two. All of that is those are telling details that this seemed to be a circle, right? And they suggested dividing everything by two, and then especially with that half there, and so don't try to complete the square. You'll have some horrible fractions to deal with, and so comparing it with the general equation could really help you to quickly figure out the center as well as the radius, right? Good. Um, so we're not gonna. I guess in the last course that you did, you probably went into um, tangent to a circle. How a particular line is a tangent to a circle because the distance, you all know the distance is a distance formula. So if you know the center of the circle and you know where the line is, you can actually figure out how far the line is from that point. And if it's equal to the radius of the circle, well, then you know that's a tangent and so, right? All of that should have been covered in the previous course, right? And then there's this condition about orthogonal circles and concentric circles and circles that touch and all of that, right? I'm going to skip over all of that. That those should all be in a previous course, right? Good. So I want to switch over a little to the parabola. Give me a second. Let me find parabolas. Make it a little bigger. So I guess you can see this, right? And just a quick review. They're giving you a little um, definition there of a parabola, right? It's basically a set of all points, they say, in a plane that are equidistant from a given line and a given point not on the line, right? And they're telling you the given line, they call it a directrix. And the given point that we're talking about here is the focus, right? Then you know the other parts, and so you heard of the vortex of the parabola, the axis of the parabola. You have probably heard also something called the latus rectum and all of that, right? Um, so basically the anatomy of a parabola, right? See the axis of it, where it's open towards, and so, right? Focus, the vortex, the latus rectum is going to be somewhere behind there. The directrix is there as well. Um, so, see, all the points in the parabola are equidistant from the focus and the directrix, right? That's a special property of it. You might have gone through these equations for the parabola when they're open to the, what do you call that? Open to the right and open to the left, but oriented on the x-axis. That's the form of the equation that you'll see, y squared equal 4px, and y squared equal 4px, where p is now negative, right? Um, that's the form of the parabola when it's oriented or it's open to the positive or the negative side of the x-axis. In this case, the vortex seemed to be at the origin there, right? All of this you had to be introduced to in a previous course. And then if you, we're more familiar with this parabola, right? From even the CXC level, where it's open to the positive or the negative y-axis, right? And the general equation there you have, well, I should say as a standard equation. Um, x squared equal 4py, and what's the next one? X squared equal 4py. One time p is positive, the other time p is negative, right? Um, so I think you are familiar with this kind of thing from the previous course. What we want to go to is when the vortex of the parabola is not on the origin. It's not at the origin, right? It's somewhat translated and it's somewhere in one of the quadrants, right? So we'll take the situation where I'm not going to go through all of this. I'll send these notes to you. I want to go straight to, give me a second. Yeah, this here, right? This is what we go straight to. So here, your parabola is basically oriented. Um, yes, it's parallel to the y-axis or parallel to the x-axis, but the center is not at the origin, right? So now you're in your new, or what we call it, I keep using the word center, nobody's correcting me. When we talk about the circle, we talk about the center. When we talk about the parabola, we have to speak of the vortex, right? So the vortex is not the origin. It's somewhere in one of the quadrants, right? But yet the parabola is either open up to the positive side or the negative side of the x-axis and the y-axis, right? We're going to deal with what we call rotated axes maybe next week, right? Monday or maybe next week, Friday. We'll talk a little about that. So here is what the equation now will look like, right? Um, this is what your equation is going to look like, right? So when as I say, the parabola has vortex HK and the axis is parallel to the y-axis, well, you have this, right? X minus h squared equal 4p times y minus k. And when the axis is now parallel to the x-axis, well, then you have the situation here. Watch here. Y minus k squared equal 4p times x minus h, right? So this is what we are concerned with, right? We have to memorize this or have them in our formula sheet so that maybe if you're given the equation in some other form, you can be able to convert it to look like this and then pick out maybe they want P, they want the vortex or they want the focus and, that sort of thing, the directrix. The possibilities are a whole lot, right? So, yes, you can use this equation, just rearrange what we have into this form, right? Or I can very well give you an equation and say, could you say whether it is a parabola, right? And what is its nature, whether um, it's probably oriented parallel to the y-axis or x-axis. I can ask you a lot of things, right? And you have to figure that out based on the looks of the equation and how you can rearrange it to resemble one of these forms, right? There's some nice examples. I think I did send some notes back this morning. Is this morning I'm opening those notes and see that I lost some pages somehow, right? And then I realized I have to send it back. So I sent it back to you. So look here. You give them the parabola and you have to sketch it. You give them the equation, sorry, and you have to sketch it. So and then they tell you locate the focus and the directrix. Look at that. Right? So what do? Well, you can look at the equation and figure out what you just take the minus of that, you take the minus of this, and we don't get the vortex. Right? And you can sense that this parabola is oriented to the positive x-axis, right? It's the axis of the parabola, right? For those of you who look here, the axis here is parallel to the x-axis, right? And right away you can know that, oh, you know what? Um, y equal 3 is the line on which the axis of the parabola is oriented on, Good. And then you can probably you look at the 8 there, and you can figure out that from that 8 you can calculate p, and from that you can know, well, what's your vortex, as well as, no, we got our vortex, your focus, sorry, your focus and the directrix behind. Let me erase back everything. Yeah. So if minus 4, 3 is your vortex here, to get your focus, you have to add 2 and come this way, right? Because P is 2. So you add 2 and you come this way. So your focus, the 3 is going to remain the same because it's all happening on that line. You add 2 to -4, you get -2, and that there right there um is your focus, -2, 3. And then your directrix is going to be 2 units to the, what's that, your left, right? On the same line, y equal 3. So your directrix is going to be the line x equal -6, right? Something like that. And you're able to, get a general sketch, right? You can actually do some other things, You can do some other things. You know where the vortex is, you know where the focus is, you know where the directrix is. You can actually know where it cut the y-axis, right? Don't ask me how to do that. You should know that from your basic analytic geometry and even CXC knowledge, right? You can know all of that. So yeah, you can be given the equation, you have to sketch a graph. Um, you can very well have a situation where you give the graph and you have to pick out the equation, right, in some form. So that those abilities are critical, right? Good. So look at this one. Another example now. Example 4 I'm pointing to. Um, you have a curve here, y equals 6x squared minus 12x plus 8 is a parabola. Well, you know that, right? You know that from high school that is a parabola. But what you want to do now, you want to try to rearrange it in the form that it actually resembles the standard form, right? Um, so that's what you want to do. So you take it and you do some rearrangement using your knowledge of completing the square and so on. I think that's what you're trying to do here, right? Well, yes, is it completing the square? Yeah, I think basically something to that effect. And you're able to write it as x minus 1 square equal 1/6 y minus 2. And now that resembles a parabola that we're familiar with, right? From it, you can actually pick out the vortex. Well, the diagram is too small for you to pick out the directrix and these other things, right? But you can do it. You can do it. So you take the equation, you try to write it in this form. You try to write it in this form. So that's this here, right? And it looks like, the form x equal whatever. Um, remember, you have to have 4p something, something, Yeah. Don't forget the possibility of me giving you a graph, right? And you have to figure out, well, what's the equation of this parabola, right? And there's several ways, right? Several ways you can actually look at properties in it, right? Maybe it's vortex, maybe it's focus, maybe it's directrix. One or two of these properties might be given, and oh, the current is back now. It's too late. I'm going to wrap up this class anytime. I can go and start over class now with another computer. Yeah. Yes. So you would have to, if you were given a graph, you'd have to find whatever method. You could use any method, even an elementary method where you can pick out some points on the parabola and form the equation, right? Anybody think they can know how to do that? If I give you a graph and maybe I just give you a parabola, no, I didn't tell you any focus, any directrix, any vortex. I didn't tell you none of that. Anybody know they could actually come up with a parabola, the equation of it? Hmm? Think about it. I can't tell you everything. Think about how you'll do that. All right, so here's some additional. Well, this is a theorem, really. What are they saying here? So if you have a parabola of that form, well, they're telling you, well, how it should open and the axis of symmetry and all of that. Yeah, you know this from CX, yeah? You know that from CX. Let's maybe do a final example. You're given 2 points, the vortex and the focus, and you want to find an equation for the parabola. How do we tackle that? So we got the vortex is 1, 2, the focus is 4, 2. So what are you going to do? Well, you know the parabola will have this form. Um, you know it's going to have that form there, right? They're telling you now that, well, you know, they give you the vortex and the focus, and you will know how far apart they will be, right? So they tell you that, well, P is equals to 3. You're supposed to pick that out from what? See if we can pick out the 3 from. Let me write down what were the points again? 1, 2, and 4, 2. Right? All right, let me write that somewhere. So down here is 1, 2, and 4, 2. And the fact that you are seeing this 2 right away should give you an idea, right? That your parabola, the axis really is the axis, what you call it? It's looking like, okay, something maybe like this here, and y equal 2. It's passing through there maybe, right? Well, and from that you can pick out that, well, okay, if 1 is 1, 2, so 1 is, okay, I think I did this wrong. All right, let's say 1 is here, and then where's the other one? Is it 4? Oh gosh, I got it wrong. Yeah. So I guess the vortex is 1. Hmm. I'm very confused with this. I'm using the mouse and because my mouse is nearby. Yeah. Your vortex is 1, 2. So um, down here is 1, right? And what's the 4, 2? 4, 2 as well. Man, oh, the focus is 4, 2. All right. I lost my mouse now. Yeah. So the focus here, down here is 4, right? Down here, so 4, 2. So the distance from there to there is 3. So the distance from there to the direction to behind here is going to be 3 units as well, right? And so once we get P, well, we can know we just have to multiply by 4, and that will bring us to the value in front here, right? So we know this, we know that, we know the value of P, so 4P will be 12, and that's your equation there, right? Yes. So yeah, you can be given a lot of information. In this case, you're given, what was it again? You're given the focus and you're given the vortex, and you have to find the equation. You can probably be given the directrix and the vortex, and you have to find the equation. Sometimes you're given the naked curve, and you pick out 2 points on the curve or whatever, 3 points, depending on what you need. And maybe you might have to do some simultaneous equations probably to find the parabola. All those are possibilities, right? Yeah. All right. To be honest, I'm having a very difficult time using this laptop to do all I have to do because my desktop is right here and it's really confusing me as to where to, do stuff. So I will end the class here, right? I will end the class here. Let me just stop this recording.